Okay, it's Roger from Mud Fossil University once again, and today we're going to go through sonoluminescence. And before we can get to that, you have to understand magnetism. You have to understand the particle of the nature of the particles within magnetism. Now, this is, you see what it says here? Bigger magnets in the inverted direction in the center. And these are other magnets in a different polarity in the outside. And what it does is it creates a positive core with a negative component as well, and the negative component just barely exceeds the positive component. Now watch what happens. I'm just going to let this run. Now what he's going to do is he's going to show this magnet. He brings it up to a boom. Look at that. Now you see what it's doing there? And that is stuck there. He's going to shake it around. You'll see it does not want to leave there, and it does not want to get any closer. So that is quantum. That is exactly quantum. And he'll shake it, and you'll see it'll go back and forth. Now, that, when you see it bouncing around like that, you see it? All right, I'm going to just stop. There's no sense in bothering anymore. It will never hit the core, and it will never leave under its own power. All right, something is going to drive this away from this core, or pull it away from the core, or the core is going to change its potential so that it pushes the electron away. Now, that's the key you have to understand. Don't think of magnetism, zip, bang, it's together, or it's apart. No, 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 no. They can be in that orientation. That is quantum, and that is the nature of atomic and molecular interactions. And that accounts for everything that I will show you in sonoluminescence and all molecular interaction. And I believe this is what's been being missed. So I'm going to show you the evidence we have. And I have copious amounts of evidence. And the first thing I'll show you is the most important thing. Okay, these are the slow-mo guys once again. Fabulous guys. Now, they're setting off a firecracker in water. It's going to make a huge, well, it's going to make a cavity in the water. And what you'll see is on this side, you're going to see the exterior part of the explosion. This side is less of a exposure. You're going to see the inside, less light. Now, what I want you to take away from it is as it expands, you're going to see tiny little particles start to show up. And there'll be all kind of different colors. And Hutchinson said the same thing. You see it in the Chinese water bowl experiment. It emulates the things in space. It appears to be that this is creating sonoluminescence, which we know it is. But in addition to that, it appears that it's dragging electrons out of the water, and then as it collapses, it crushes that electron mass. And what I'm saying is if there was an electrode in there, and we could open it and crush it, and open it and crush it, we should be able to shoot those electrons out of there through a wire. Now, watch what's happening here, and I'll point out that it's really cool. Now, here it goes. It's opening up. You're going to see it start to form here. Here, I'm going to open this whole thing up so you can see the whole deal. Watch. You see that? You see all the electrons showing? You see them over here starting to show up? This is where there's such they're trying to drag electrons out of the water. That's my explanation. That's all I can tell you. You see them, all the little colored lights? All the little colored lights? Now it'll start to collapse. Oops, can you see that? As it collapses, it starts to boil those electrons. They can't get out of here. They can't get back into the water. Some kind of hydrophobic action. It's crush, 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 poof. Now they can't hold it anymore. They explode. That's the external portion. It's all over. Okay, this is amazing. They shot the firecracker off. Now they're on the surface. Watch what happens. This will show you how much explosive force is in that secondary explosion, which is the sonoluminescent explosion. The first explosion you're going to see, the water will rise, and that's the firecracker's explosiveness. Then the second explosion is from the sonoluminescence. Now watch, and you're going to see the same particles, all these little red and blue and green little particles, because that is where they disassociate. Watch what happens. Boof, there it goes. Now it's rising. And you'll see it'll stop rising, and then it will start to compress. There it goes. There's your little lights. Now it's starting to compress. And as you see it coming down, what? And then all of a sudden, whoa! That's when she caught the sonoluminescence. Look at that. much more reactive, look at that, than the firecracker. So just something for you to see. Okay, this is, I believe, the atmosphere that they had these dust particles in that the Russians did, and I'll show you that experiment in a minute. And they were in this particular plasma, they call it, which is nothing more than an environment of gases that are loaded with electrons, extra electrons. That's my claim. You see this statement here? It's exactly what we're saying. They're saying the method of producing this particular plasma, which is loading the electrons, is usually the discharge needed to produce CAP, which is the pressure, the plasma, is induced electrically. What they mean is they're putting frequencies into it and forcing the electricity into it, just like you do in a motor. When you run a motor, you're forcing electricity into a wire. That's exactly what they're doing here, only they're doing it in a different manner. They're shaking the electrons into that condition. All right, I'm going to set this up for you. We just talked about plasma. You know that plasma is nothing more than a bunch of a gas with a bunch of different electrons stuffed into those molecules. So you got extra electrons. Now let's watch what happens here. Now this is Russian, so I'm not going to have any sound. But you see what first happened? That this one here. These are all four are the same shot at the same time in different cameras, different filters and that type of thing. Now, what I want you to take away from this is these are particles. These are particles, it appears to be deep inside the structure that we can't see on these surfaces. Now, what you want to look at here is how the molecules turn into little chains and things. These create all kind of little eddies and forces. This looks like it's like a rocket ship running around in a circle. These are little tiny particles that look exactly like the sonoluminescence. So here's what's going on. Let's watch. Now, you see, watch, you can go back and forth on this and play around, but you see the particles? You see them here? You see them here? You see what's happening up there? It's bouncing back and forth and catching itself. Now, I'm not sure if they're guiding, if they're doing anything different here. In other words, I'm not sure if they're pulsing it with anything, or it's in a magnetic field, or what is causing that movement, because I really can't tell what they did. But I can see the particles, and they're very similar to what I'll show you in the sonoluminescence. Okay, just quickly, just to make sure you understand what a resonator is. It just makes a frequency. You see how this thing is shaking? It's shaking. And what they do is it shakes the molecular nature of water. Now, I want to show you something else. Okay, just real quickly, this guy is doing the same thing he's doing sonoluminescence. And he's got a resonator right here. It's vibrating the water and creating the sonoluminescent balls that collapse. And when they collapse, they create tons of heat. It's simple as that. And this is the return that comes back. He's running with a 9-volt battery and a little resonator. And he boils a gallon of water in a couple of minutes. It's just absolutely amazing. And trust me, a 9-volt battery doesn't do a whole lot of water boiling. Okay, once again, this is the slow-mo guys, fabulous experimenters, and they have, I believe this is 2,500 frames per second. Could be wrong about that, but it'll show later. Anyway, this is what's called a Chinese water spouting bowl. And if you rub these handles, which you will in a minute, it will start to vibrate rapidly. So let's just go ahead and play this, and I'll try to explain what's going on and how it plays into our stuff. He just shook it, and you're going to see what he did. All he does is go back and forth like this. Now watch, see he's doing it? All of a sudden it will start to vibrate. Now he's just going back and forth, and it's, yeah, 2,500 frame. You can't hardly see his hands moving because it's so many frames in every second. Now watch over here. This is the most important. You see, I'll stop it right here. Watch as these waves begin to propagate. Now don't forget, this is the actual metal of the bowl. This is the actual water, and he is in the shade here, so that what we're going to see is not reflection of light. It is sonoluminescence. Now watch. Here it goes. You see these waves start to boom, boom, boom. See them? Watch right here. Watch what's happening. The waves are, what I am claiming, and I don't know how you can see it any other way, it's sucking electrons out of the metal, pulling them into the water with that vibration, and as they come into the water, they explode in what's called sonoluminescence. All I can tell you is what I see, you see. Now watch. See it? Boom, 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 boom. See it? Boom. Watch up here. Watch the flashes of light. This is in the dark. This is not any reflection of light to the surface. Watch. Boom, 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 boom. And they come, see? Boom, boom. It's filling this water now with electrons. That is loading this water. Okay? All movement is loading electrons. All heat is, and energy is and electricity is loading electrons into a different particular matter. And we can see it doing it right here. And they are just flooding in here. All right? And you can see these are not radiated. This is not from the light shining. These are actual particles. You see them? So what's the takeaway from this? The takeaway is that this is vibration. He's making this thing vibrate. It's going like this. That vibration is making this thing literally pulsate like a drum. Watch the actual, see it? Watch. The actual metal is vibrating. Look at the water going flying up in the air. There's a tremendous amount of activity here. And there's, watch the holes in the water that come out. These things are just flying like crazy. There's a ton of energy being produced by his hands just barely rubbing back and forth. Now, what else is there involved here? It's not just his skin. This has to be wet. This is brass. It has to be wet, and he rubs it on his skin. Now, I don't know about other materials for sure, but I bet you any money if you put oil on there, it's not going to happen. If you put soap in the water, the surface tension would not allow it to rip itself like it is. I don't know. There's a ton of experiments you can do with this, but I'm seeing sonoluminescence. That's my point. Let's start it right here. This explains how
enough for a small light bulb. Hutchison made a
75
60-pound
watts
cannonball rise off the table.
Cannonball.
It would also fuse dissimilar materials, heat metal but not burn the wood it sat on, shatter metal as well as change its crystalline structure. This was something to write home about.
Beginning of 1980, experimenting with all the electromagnetics and electrostatic equipments I had at the time, I started to notice some very, very unusual effects, such as a room being filled up very quickly with multicolored lights.
All right, there it is. There it is. You saw what happened with the explosion in the water. It shook the water so violently that it dragged the electrons in and just lit them up. He's seeing the same thing, but he's shaking, literally vibrating in such short distances, the frequencies. They're in what's called angstrom units. Molecules and atoms have their orbital electrons very close. You know, in molecular terms, they're in so tiny little distances that it's unimaginable. So they're called angstrom units. And if you can make these waves, which nobody really does, Tesla did, but if you can make these waves generate in such incredibly short up and down frequencies, they're literally shaking things up and down, just like you shake a towel. And they're shaking, shaking. Now, if they shake it enough, and the distance is so close to the nucleus that they're still shaking between that distance, then the electron will leave, because it'll just be thrown out of its place. As simple as that. Just like the bridge, the big bridge that goes wobble, 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 and all of a sudden it goes flying. And the same thing is going to happen to these electrons. They're not going to just fall off of there in one big whack. You know, maybe a nuclear explosion will throw some out, but they're not going to just walk away and you shake them a little bit and they all go away. No, you have to create, you have to load. And then you've got your load is in there, then they'll start to radiate. That's the way electricity works. It's a loading factor. You know, I mean, there is excessive, extreme, huge quantities of electricity that can be sent almost instantaneously. But I was in the business for many years, and we had what we call as a POI, power on initiation. You think when you push in something, you turn it on, everything happens, electricity's right there. No. It comes up, and if you can look at it in real time, in these kind of frequencies I'm talking about, you would see you'd be standing there for a week before you ever got to your 110 volts. It comes in at zero. It didn't come in at 110 volts, it comes in at zero. It has to fill all of the electronics in the circuitry and load up the capacitors. And then it's all filtered at this point, and then there's what's called power on initiation, which is the pulse that turns on the devices, because you can't start them up at 3, 4, 5, 8, 10, 15, 20 volts. They have to be 110 volts, or once it regulates itself back down to 5 volts, which is what computers run at. Then it doesn't, but it'll be 1 volt, 2 volt, 3, 4, 5. When it hits 5 volts, all right, we're all set to go. Everybody can think at this level, shoot it out to the guys. And that's when you get your electricity. So electricity is not spontaneous combustion. Trust me, it's not. It takes a while to do what it does. But for us, it's so fast that it's inconsequential. But when you deal in an electronic realm, it becomes extremely consequential. I now listen to what he has to say here.
Well, some time ago, I was doing some testing and got into some big trouble after I levitated a toy UFO and some other objects.
Apparently, John's experiments were lifting objects in nearby homes, and the neighbors called the police.
The police came full bore in here with engineers, inspectors. They photographed all the equipments very carefully. It's almost like if you called in a cleaning crew. They didn't touch anything. It's like they made everything look neater for some strange reason.
It seems like someone in the shadows still cares what our hero is up to. Frustrated by authorities and lack of recognition, John has been spending time developing his new project, batteries that last forever, based on the somewhat bizarre zero-point energy theory.
All right, I'm not going to go any further because it goes deep, and this guy can do this. And I know for absolutely guarantee you, this guy can do what he's saying, and he has done things that no one else can do. He levitates things. What I saw, and I've been following his work very carefully, well, not real carefully, but I've been following as much as I can. And he's got different types of metals that he fuses together, and it creates an electron flow. And there's an absolute method to his madness. And I'm going to show you a little portion where he talks about these particles that we were seeing. Now, they're saying that things levitated. Now, why does the broom go? Why does the liquid go? Why does the bowling ball go? It's the exact correct frequencies. And why does water light up like this? He hit the frequencies of the water, the molecules of H2O that are in the air. You always have moisture in your air, and he hit that, and it resonated them and turned them into little glowing, almost look like stars in the sky, right in his room, and he explains that. Okay, once again, all this relates to what Hutchinson is doing too, and this is he had this whole array of dials and knobs and Tesla equipment and resonators and all kinds of different transformers and so forth, creating frequencies and vibrations within the atmosphere in his lab there. Now, all I can see is him going all these different things, and they go all different frequencies are produced by how you affect the input of the wave. Now, if he can get a frequency that matches the distance in the nucleus of the electron to the nucleus, somehow he's pushing those electrons away, and he creates anti-gravity. So let's watch what it says here and listen.
There is no one machine, just a lot of old Army surplus gear, randomly tuned by John.
See what he's doing?
No one knows how it works. John has apparently figured out the right combination of radio waves and electrical energy to create the effect. If it could be proven, its impact would be huge. You'd have to rewrite most of the science textbooks, especially the part about... An example of this kind of random event happened in 1989, when a visiting Vancouver news crew was setting up at John's lab to film the Hutchison effect. The target area was that yellow crate with the metal objects. But to everyone's shock, a sponge in the back of the room took off into the air and then fell back down. John didn't actually see it and was genuinely surprised.
Like that, it went up and hit the ceiling 1 second, maybe 2 seconds, and then came down. Kidding, no?
All right, I just want to explain, and he can levitate literally anything. I see bowling balls and glass and liquid out of the glass and leave the glass. So all I can say is that every single molecule has its own distance and its own configuration of electrons from their nuclear bits. If you can find the frequency that forces those electrons away from their nuclear bits and draws the negativeness out of the nuclear portion, I believe that creates a positive nucleus which will oppose the Earth, and that gives you levitation. And it seems to be that is the case with hydrogen as well, because that goes up in the air. Why does that go up in the air? It has a positive nucleus. That's all I can think.